Hello, my name is Rich Howard, owner of Architectural Builder Supply, and the project that I'm working on now is making the wood underliner that you're going to see when you go to the Mexican restaurant and you order fajitas. And that cast iron griddle comes out so hot that it's impossible to touch that. But there's always a piece of wood the griddle sits on. So what we're making actually is 50 of those underliners. Okay, we're going to do a CN74. Hopefully we're going to do it correctly. I watched Chris Burns do it initially when the ATC went in, but I recall that it was just a rather boring procedure. So let's take a look. I know that we need to do a C3 before we do a CN74. We're not doing any C anythings until we go through the instructions at least once. When I spoke with ShopBot earlier, they were really clear that it's all covered in the automatic tool changer installation manual, and it is. And in fact, of this 2022 edition, I think there's 8 pages, but it's all really large font. So let's dive into it. Let's actually look at this together. I want to understand it on a first run before we start telling the machine to move stuff. So we've got calibrating the ATC, home the machine, type C3 in the ShopBot software or use the XY home icon in the position window. The tool should end up at the home location previously set in the ShopBot setup routine. Okay. Calibration, CN74. The ATC calibration routine is program defined and record the clip locations. This document will walk through the process. Great. Speaking of that, let me walk through some process here. So it says the ATC calibration routine, CN74, is program defined and records the clip locations. This document will walk you through the process. Take out the calibration clip and drill rod that came with the ATC. Now what I can tell you is how important Chris Burns impressed on me this little Ziploc bag was. So it's been safely kept with all of my ShopBot manuals and whatnot. Connect the Wago plug to the mating socket on the YZ car. This is where I would like to have a photo of the YZ car. I'm pretty convinced that that's what we're doing. Oh, baby. There's a lot happening there. Are we tall enough? Are we high enough? On the YZ car. I'm extremely positive that this is a clip on the YZ car. I'm going to do a quick internet search for ShopBot YZ car and see what comes up. Yeah, that's going to be the YZ car. So the red calibration clip will be clipped to the bottom of an empty tool holder as it is moved through all the clip positions. The black clip will be clipped to the tool holder that is in the spindle. Yeah, I think the empty tool holder is shown here. Type CN74 into the ShopBot 3 software to begin the routine. Enter the number of tool clips that are mounted on the ATC. Click yes if X and Y are zeroed, which we would because we'll have run a C3. Yeah, otherwise click no and return to C3. Okay, determining Z height for calibration. Press the green button located on the inside of the spindle and insert an empty tool hole. Okay, so what they're saying over here is the red calibration clip will be clipped to an empty tool holder in the spindle. Okay, so let's continue on with this. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, not sure where we left off, but let's pick up. Okay, C3. Determine Z height for calibration. Press the green button located on the side of the spindle and insert an empty tool holder. Okay, that's super easy. Place a second empty tool holder inverted in clip position 1. Love it. Place the black grounding clip on the tool in the spindle. Okay, so we're connected to the YZ car. We've got the black on an empty tool holder in the spindle, and we've got an empty tool holder installed upside down in clip 1. Okay. Place the red calibration clip on the bottom of the inverted tool in position 1. Got it. Okay, so clearly we're going through CN74. Click OK to make the Z-axis move down and touch the inverted tool holder, then raise up to a safe distance and move back towards Y0. Okay, so calibration clip on the bottom of the inverted tool. Awesome. And now I recall what Chris Burns was doing is he was moving this to every single position. That's what was so monotonous about it. Click OK to make the Z-axis move down and touch off the inverted tool holder, then raise up to a safe distance and move back towards Y = 0. So come up and then back. Press the green button to remove the empty tool holder in the spindle. Caution, grasp the tool holder before pressing the green button. Yeah, you hit the green button, it'll fall to the floor. I don't know that, but yesterday my left hand was on the green button. My right hand was below the spindle, but I wasn't in that microsecond completely ready to receive the spindle, the tool holder, and I was surprised as to how it felt like it shot into my hand. All right, now let's look at the next step here. Determine XY position of tool clips. Snap the 1/4-inch collet into the collet nut. So we've removed it from the spindle. I imagine we're talking about the same tool holder. Then screw the assembly onto the tool holder. Insert the 1/4-inch drill rod, into the collet and tighten. Press the green button to place the tool holder with the drill rod back into the spindle. Make sure grounding clip is on the drill rod and the calibration clip is on the bottom of tool holder 1. I know what's going to happen. I recall now. This is actually easy. Clip the grounding clip to the top of the drill rod and the red calibration clip to the bottom of the inverted tool holder. You still have that one in the bottom of your clip, your tool holder clip. Use the keypad to lower the stylus tip, which imagine they mean the drill rod, approximately a 1/4-inch below the top edge of the tool holder in clip 1. Press escape when finished with keypad. This should only be a move in the Z-axis so that the tip of the drill rod is below the top edge of inverted clip. Do not move X and Y. So get that tucked down there, below the top edge of the inverted tool holder, not inverted clip. The clip's not inverted, the tool holder is. The ShopBot will run a routine and then prompt for the next position, hit escape to continue. And what I think it does is it just goes like this to determine the actual position of that. Okay. Now it goes on to say, the routine will start on the outside edges before touching off of the inside edges. Move the inverted tool holder to the next clip position and repeat the procedure for every clip position indicated at the beginning of the file. Oh, and I recall now, what was happening was Chris was down here in the pit moving the inverted tool holder down along, and I was the dummy sitting here hitting OK, OK, OK. So that's how that was actually working. This will require me walking around the tool because I'm here alone doing this. That's no problem. All right. The routine will start the outside edges before touching off the inside edges. Move the inverted tool holder to the next clip position and repeat the procedure for every clip position indicated at the beginning of the file. Okay. If something goes wrong during the file, the calibration routine will need to be restarted C3. I'm going to take a lap right now. We'll pick this up right here. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. If something goes wrong, you'll need to rerun the calibration. Got it. Read every screen and double check before clicking to the next stage. Done properly, this will only need to be done once. As I roll my eyes. Step 3. Set fixed Z0 plate location. Run the homing routine. C3 to be sure everything is zeroed. Load the file ATC fix Z plate located. Got it. This file will set the location of the fixed Z0 plate to set a base 0 height of the bits. This should only need to be run during the setup procedures. Click OK. Use the keypad to move the spindle over the center of the fixed Z0 plate. Once satisfied with the positioning of the spindle, hit escape. This will set the fixed Z0 plate location in the X and Y. Good. Set up tool holder. Locate the tool holder. Collet nut and desired bit. Make sure the collet is sized for the shank diameter of the bit that's being installed. Okay, so this is just us setting up bits, all of it. Okay, we've done that. I have a full complement of tool holders and bits in my ATC barn. Place the loaded tool holders in the desired clip locations. Do not put one into the spindle at this time. Make sure the bits are facing down in terms of it being installed in the proper orientation. Step 5. Zero tools in rack, CN72. Daily operation. This step will zero each tool in the rack to ensure that bits of different lengths will all cut to the same depth. It is good practice to run this routine for all bits at the beginning of each work period. Absolutely. If a new bit is added to the rack or an existing bit is replaced, use this routine to calibrate it to the other bits in the rack. Ensure that there is no tool holder in the spindle. Run the homing routine, C3. A screen will open confirming that tool 0, empty spindle, is correct. Type CN72 to run the ATC 0 tools and rack file. Enter the number of the bit to 0 and then click OK. The tool will move to the fixed Z0 plate and plunge until it makes contact with the plate. And that is exactly where we had all of the trouble because our wire from that switch inside of the Z0 was broken. 0 bit 1. If more bits are needed, yes, you'll hit yes. Enter the bit that you're going to zero next and keep going on until you do all of them. I'll go 1 through 9 at step 5. Change tools. C1. Insert bit into conical tool holder and place it in the desired clip location. Type C1 to run the custom number 1. Change tools. So right now there's no tool in the spindle. C1 is going to say, what bit do you want me to go pick up? A screen will ask which tool to be selected. I'm going to do 5. Once that tool is entered, click OK and the ATC will drop off the current tool, because we didn't do a C10 up here. It'll drop off whatever in there. For me, it will be tool 9 because that's the last tool. And select the desired tool. If there is currently a tool in the spindle, be sure that there is an empty tool clip in the correct location. Meaning when you pull a bit out, a tool out of your holder, don't put one back in there. If all 9 are filled, or whatever your number is, and you've got one in the spindle, it won't have anywhere to stick it. Okay, so C1, you're going to change tools. To check what tool the software thinks is in the spindle head, open SB Parts Custom ATC Local Data, ATC Tool Variables. That file we've been in. That's nice to know what tool your machine has registered as in the spindle. Look at line 3 at tool in equal current tool. We'll show the last tool change to. Get plate offset, CN73. This is when you're going to zero to your machine bed. The tool will now test the homing on all axes, C3 routine. This file is included with ShopBot versions 3.8.2 or later. Users of earlier version can add it by contacting ShopBot. Okay, we have that. This routine will establish where the C3 XYZ0 routine will set the Z0 level. Normally this is the table bed. This routine needs to be run whenever the location of the table bed has changed. Interesting. Well, I don't remember doing a CN73 on my machine bed, knowing that I had at some point surfaced that down, which isn't a problem, I don't think, because admittedly, I am always zeroing to the top of the workpiece, which is overriding that, it's incorporating that value. This routine needs to be run whenever the location of the table bed has changed, such as after resurfacing the spoil board. If a tool is not loaded in the spindle, select one by running this routine. Any tool can be used as they've all been zeroed to the fixed plate, Z0 fixed plate. Type CN73 in the ShopBot software to run the ATC get plate offset file. Use the keypad to move to the location where Z level is located, 1212, 1212, 1212, 2. If zeroing to a specific fixture, move the tool over and close the keypad when the tool is at the desired position. Place the grounding clip on the collet or bit and place the regular Z0 plate above below the bit. Now we're talking just this and this. This has obviously been put down after the CN74 has been gone for. When the plate is removed, the tool will confirm the proximity switch locations and new Z0 level. Every time the C3 routine is run, the tool will be zeroed at that stored level, which is why anytime the height of the machine bed or the spoil board changes, that's why you've got to rerun a CN73. Pay attention to where the Z0 is set in the cam file to avoid damaging the table surface or cutting the wrong depth. That is for sure. Okay, we're in the home stretch. Step 8, 0 to various Z heights, C2. Okay, so we're just doing a C2. ATC users will only have to zero one bit in their material or to their material or bed height each time the Z0 position is changed. The remaining bits in the tool rack will also reference the new position. So when we do the CN73, we only need to do it with one bit because we've already done the CN72. It knows where all the bits are. When the bit is located over the area to be zeroed, go for it. Place the Z0 plate under the bit, place the grounding clip on it. So what they're saying is, place the Z0 plate under the bit and place the grounding clip on it. Put it on the bit, don't put it on the collet. I learned the hard way that you don't always create a closed circuit when you clamp to the collet. Clip it to the bit, to the mill, to the end mill, to the tool, not the collet. The Z-axis will touch off the plate twice. As Chris Burns says, it'll go back for a second opinion. And record this distance for use on all the tools until the Z offset is reset. This records a Z offset height within the ShopBot user variables and applies this to all other tools in the rack. Note that the Z offset is reset to the Z home position anytime a C3 routine is run. To permanently change the Z home position, refer to the Get Plate Offset CN73 section of this document. We just said that. If you need to change it, you're going to run a CN73, and you're going to change it if you resurface your spoil board, or if there's another reason, like it had mentioned a fixture. Regularly used ATC files. C1, change tool. C2, 0. Z-axis using the Z0 plate, like the way you would do it if you didn't have an ATC. C3, home, X, Y, and Z, using proc switches. C5s, warm up the spindle. C6 and C7, turn the spindle on and off. C9, automatic tool change called within a part file. Okay, so yeah, I wouldn't use C9. VCard Pro would probably generate that. So if I'm doing a pocket like for this job with the 5-bit, and then want to do that ball nose with the 9-bit, there should be a C9 in the exported code. CN72, 0 tools and rack. CN73, get the plate offset to the machine bed. CN74, calibration for tools in the rack. So we're done with this in terms of our once through on the installation instructions. So what's going to happen at this point is, here's what's going to happen. It's Thursday at 3 o'clock. I'm getting out of here. Tomorrow, I won't be here. The next time I'm going to revisit this is Monday. Friday, Saturday, Sunday, Monday. That's an eternity. So we're going to run a CN74. We're going to practically actually run it. The manual is going to be here, and we're going to go through it step by step. And we'll create a sub-video, a separate video of just running a CN74 for all of that. I believe that some might consider it painful to go through the droll steps of going through the manual one by one. But, you know, when all else fails, what's the saying? When all else fails, read the manual. And that's why I've learned to read it the first time. Anyway, thanks for participating so far, and let's keep moving on.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.